Hello students, last session we learnt about disaster management. Now let's learn about substances in the surroundings, their states and their properties. That is lesson number 5. If we see in our surroundings, we see many substances, but they are always in 3 states, that is solid, liquid and gaseous. As seen in the pictures, there are few examples of all 3 states. Ice cubes, solid, water, liquid, and water vapor is gaseous states example. Now let's see how changes occurs in a state of a substance. Now what is a change of state of a substance? When a substance changes from one state to another, this process is called change of a state of a substance. Now let's see a small experiment which may clear your idea. Take pieces of wax in a bowl and adjust it to the clamp stand. Now place a spirit lamp below it and start heating. On heating, you will see the pieces of wax are converted into liquid. On further heating, they evaporate into a gaseous state. So this is a best example to see how a solid gets converted into liquid and a liquid gets converted into a gaseous state. Now let's see few more examples related to the topic. Which substances in our daily use freeze in winter? Answer is ghee and coconut oil. Which liquid in our daily use change into vapor? The answer is perfume, petrol and spirit. Now, third question. Which solid in our daily use directly changes into a gas? Answer is camphor, naphthalene balls and ammonium chloride. Naphthalene balls म्हणजे डांबर गोळ्या. From above question and answers, we conclude that the state of a substance changes if it is heated or cooled. Every substance in the surroundings is found in either the solid, liquid or gaseous state. The changes occurs due to the intermolecular space. When we heat a substance, the intermolecular space increases and hence a solid on heating converts into liquid. When we freeze a substance, the intermolecular space decreases and hence a liquid changes into solid. Let's see the above table. First is solids. Example of solid is a piece of iron. Shape of solid, it has a shape of its own. It retains its shape no matter how it is kept. Volume, it has definite volume. Solids like sugar, sand, when poured on a flat surface, form a heap. Liquids, water, spirit, oil are the examples. Shape, do not have definite shape of its own. Takes the shape of a container. Volume, it has specific volume. Occupies definite portion of a container. Spreads on a flat surface on pouring. Flows downward along a slope. Third is gases. Example, air. Shape. Does not have a shape of its own. Occupies all available spaces. Volume. Does not have a definite volume. On changing the pressure on a gas in a closed container, its volume also changes. To understand this more, example, when you fill in air in a balloon, it expands. And when you press a balloon by both the hands, it contracts. Heat and change of physical state. J. Willard Gibbs showed that characteristics, properties of a substance depends on its physical state and the arrangement of particles in it. You have learned that change in the physical state of a substance is an effect of amount of heat in it. On gaining heat, the substance changes from solid to liquid and liquid to gas. On the other hand, when the substance cools or loses heat, it changes from gaseous to liquid and liquid to solid state. To understand more, let's see below flowchart. The state of a substance changes when a specific amount of heat is gained or lost. The change in the physical state is determined on how a substance is hot or cold. Now, how do we tell a substance is hot or cold? At home, our mothers check our forehead to check the temperature we have. But that is not an exact way to measure the temperature. So what do we use to measure the temperature? It's called thermometer. A thermometer is used to measure temperature. Degree Celsius is the unit of measuring temperature. There are several types of thermometers available nowadays. Digital thermometers are more frequently used in day-to-day life. Water. Now let's see what is boiling of water. Water is continuously evaporating. We know that water spilt on the floor dries up slowly on its own. What is that? That is nothing but evaporation of water. This evaporation occurs from the surface of the water. What happens when water boils? As the water gets heated, its temperature increases and it evaporates at a very faster rate. When water is kept on a stove, it attains a particular temperature or level of heat. It reaches to a particular level of temperature. This evaporation takes place in all parts of the body of water. Then we see water bubbles rising at a faster and faster rate to the surface and steam mixing in the air. पाण्याच्या बुडबुड्या येतात, वर येतात आणि पाणी वर यायला लागतं आणि मग स्टीम येऊन ते हवेत मिक्स होतं. This is called boiling of water or ebullition. At a sea level, pure water boils at 100 degree centigrade. Means here the water is not kept on a stove, but due to the atmospheric pressure, sea water boils at 100 degree centigrade. This is boiling point of water. So 100 degree centigrade is the boiling point of the water. At this temperature, the water starts boiling. When water vapor cools, it is converted into water again. When the water vapor is cooled, it again gets converted into liquid. That is, gaseous state is converted into liquid. To see an easy example, when you are boiling water on a stove and it is covered with the lid, few of the steam is attached to the surface of the plate. After some time, when you remove that plate and see, the vapor is converted into liquid, that is into water. This process is called condensation. Condensation of steam also takes place at 100 degree centigrade. This means that boiling point and condensation point of water are same. Now see the above flow chart. To explain this flow chart, let's take an example of an ice. When we take a piece of ice and keep it at a normal room temperature, it starts melting. So that is, a solid gets converted into liquid. When we boil that liquid, it gets converted into water vapor. Now, when we stop boiling or heating and cool the vapor, it again gets converted into liquid. That is condensation. And when this liquid is again kept into fridge, it starts freezing. We saw what is boiling. Now let's see what is freezing. When the water is kept in a fridge or on a ice, it becomes cooler and cooler. It means its temperature falls. At a certain temperature, water does not cool any longer, but it starts freezing and gets converted into ice. The temperature at which this happens is called the freezing point of water. And the freezing point of water is 0 degree Celsius. The temperature of a substance can fall below 0 degree Celsius. ह्याचं जर उदाहरण द्यायचं झालं तर आपल्या घरातला रेफ्रिजरेटर. The temperature of air in freezer of a refrigerator is around minus 18 degree Celsius. It can be read as minus 18 degree Celsius. When ice gets heated, it starts melting or changing into liquid again, which we have seen in the flow chart earlier. Ice melts at 0 degree Celsius. It means that the freezing point and the melting point of water are one and the same, that is 0 degree Celsius. Each substance has specific boiling point, which is also its condensation point, that is 100 degree Celsius. As well, each substance has specific melting point, which is same the temperature at which a substance 0 degree Celsius, while heating is same as the temperature at which it condenses when it is cooled. Similarly, the temperature at which a substance freezes while cooling is same as the temperature at which it melts when it is heated. Now, let us see various uses of change in physical state. First, candles are melted by melting paraffin wax. Second, solid carbon dioxide, which is also called dry ice, is used to make ice cream and to keep it frozen. Third, liquid nitrogen is used in animal husbandry. Fourth, sand is melted to make glass. Fifth, metals like gold and silver are melted to make ornaments. Sixth, iron is melted to make different tools. We saw boiling, freezing. Now let's see what sublimation. Iodine crystals do not melt on heating, but changes directly to the gaseous state. When these fumes of iodine hit the walls of a funnel, they cool to form solid crystals of iodine and stick to the funnel walls. Thus, on heating, iodine does not melt and change into liquid but directly changes into gaseous state. So, let's define sublimation. The change of a solid substance directly into a gas or a vapor without first changing into liquid is called sublimation.